Today we will be talking about the physics of alpine skiing. Newton's first law of motion states that an object will remain at rest or travel at a constant speed in a straight line unless acted upon by an unbalanced force. One way skiing is affected by the first law of motion is by going straight. Since the skier is starting at rest, he would stay at rest if not for the gravity pulling him down the slope. Once he is moving, he must increase the friction between his skis and the snow to slow or stop. Newton's second law of motion states that an object with more mass will have more inertia and it will take more force to move the object. One way this relates to alpine skiing is because if a skier turns their skis so they are slightly to the side, the friction on the snow will be much greater than if he is going straight down the mountain. This will reduce his net force and cause him to have less acceleration around the turns. Newton's third law of motion states that for every action has an equal and opposite reaction. Pushing with poles is a good example of the third law of motion. As the pole's force is going backwards, the snow pushes back and the skier accelerates forwards. When calculating speed, I started by finding the length of the men's downhill course, which is 2,857 meters. Then I took that divided by the time of the first place run, which was 100.25 seconds. This equals out to 28.4 meters per second. I did the same thing for the men's downhill world record and got 45 meters per second. Drag has a big effect on alpine skiing. Drag is always opposite to the object motion, and the drag's force increases as the object moves faster. Drag can be decreased by the athlete being more aerodynamic and wearing different gear and suits. Drag will make the athlete go slower. Gravity also has a big effect on alpine skiing. The athlete gains speed by converting gravitational potential energy into kinetic energy of motion. So the more they descend down the hill, the faster they go.